Illustrative Math, Algebra 2, Unit 6, Lesson 7 is called Finding Unknown Coordinates on a Circle. All right, what do you notice? What do you wonder? Pause the video, try to come up with as many notices and wonders that you can think of. All right, so a couple things here. Right away, I'm looking here and I say, okay, a circle on the right has twice the radius of the circle on the left. You can tell by looking here, radius is 1, radius is 2, obviously double. Both triangles are right triangles here. We have a right triangle, we have a right triangle. Kind of looks like it's in the same position as well. Points A and point D are in quadrant 2. If you can't remember the quadrants, this is quadrant 1, this is quadrant 2. Usually they use Roman numerals for quadrants. This is quadrant 3. Oops, sorry. And then this is quadrant 4. Okay, so they're both in quadrant 2. It looks like they're similar. How do I know that they're similar? Technically, this angle right here and this angle right there, those are going to be the same because the x-axis is pi radians. So pi minus theta is going to be the angle for right there and also for right there because the whole 180 degrees is pi radians, and then if you subtract theta, you would get the same number. We just don't know what theta is. We can't actually find a numerical value. Okay, so some wonders. What do you wonder here? Is one triangle dilation? Well, if we think that they're similar because of angle-angle similarity, like I just showed you here, we have the right angle, and then we have those angles are theta minus, or 180 minus theta, or pi minus theta. We would know that similar triangles are a dilation, so that would probably be a yes. What are the coordinates of labeled points without coordinates? So in other words, C, D, and F. What are these coordinates? They're not labeled. There's no points there at C, no point at D, no point at F. E is 0, 0, B is 0, 0, and they gave us A. So could I find those? What's the measure of angle theta? Theta looks like that. Right there, what's that measure? Since it appears the triangle DEF is triangle ABC multiplied by a scale factor of 2 or dilated by a scale factor of 2, can I just multiply the x and y coordinates of A by 2 to get D? Okay, that's a good question. Something that you did in geometry, probably, the answer is probably yes, if you think back to dilations in geometry class. But there's a little warm up there, just get some conversation going. All right, so here's a clock face. The length of the minute hand on a clock is 5 inches, and the center of the clock is at 0, 0 on a coordinate plane. Determine the coordinates of the end of the minute hand at the following times. Explain or show your reasoning, okay? All right, so here is my minute hand. So 45 minutes after the hour. So obviously the hour starts right here. So 15, 30, 45 right there. So if this is 0, 0, think of it like these are the axes here. So it looks like I just moved left 15 if my radius, I'm sorry, left 5 if my radius is 5. So this one here looks like -5, 0 because the radius is 5. I don't go up and down, I just go left 5. So that's right there. 10 minutes after the hour. So that would be right there. So obviously they're both positive. You might remember the x coordinate would be the cosine of, this is pi over 6 because technically, if I split this up right here, split up half a circle, I'd have 1, 2, 3, 4, 5, 6 sections. So it's cosine of pi over 6 is the x-coordinate, and the y-coordinate is sine of pi over 6. Okay? Erase all that. But that would be for B. And then C, 40 minutes after the hour. So 30, 40. So we move it right there. So then when we look here, it looks like this is the same angle right here as pi over 6. So what I could do here, because you see how it's 1/6 of the circle, but the only difference is I got to change the signs now. So, you could do this a couple different ways. You could say that it's all the way over here at 7 pi over 6. So for C, I guess I'll come over here for C. You could say the x-coordinate is cosine of 7 pi over 6, comma, sine of 7 pi over 6. That would work because we have an extra pi over 6 that we go. So there's 6 of them and then an extra 1, so 7 pi over 6 is. Or you could say this angle here is pi over 6. It's kind of the same angle here. So the only difference is my coordinate is going to, if this is my coordinate right here, if I come over here and then down here, you're changing both signs if you look at it, because it's kind of like that angle. It's the same as that angle, except my x-coordinate becomes negative. And then when I come down here, same angle here, so my y-coordinate would be negative as well. So you could say also, just say negative cosine of pi over 6 and negative sine of pi over 6, because those are kind of the same thing there. All right, the minute hand. Oh, you know what I forgot to do? Shoot, I forgot to times them by 5. Sorry. Because that would be for the unit circle with a radius of 1 unit. This is on a radius of 5. So you'd have to multiply it by 5 to extend it out on a bigger circle. Okay, so sorry about that. So the next one is kind of everything's going to be the same, except I put a 15 in front of everything. So for A, 45 minutes, it's going to be negative 15, 0. 10 minutes after, it's going to be 15 cosine of pi over 6, 15 sine of pi over 6. And then 40 minutes, it's going to be either one of these would work. I'll probably use this one because it's easier. I'm just going to say 15 cosine of 7 pi over 6 sine of 7 pi over 6. Okay. Number 3. At a certain time, the end of the minute hand of a third clock is centered at 0, 0. It has the coordinates of approximately 7.5, comma 7.5. How long is the minute hand of the clock? If each grid square is 1 inch by 1 inch, explain or show your reasoning. So if they're equal, it would have to be right here, and they're both positive. So it'd have to be right here, kind of like at a 45-degree angle. So halfway between the 1 and the 2. So what happens here is you get a right triangle created right here. Okay, so this would be, 7.5, 7.5. So the y-coordinate's 7.5. The x-coordinate's 7.5. So if I did Pythagorean's theorem there, because that's a right triangle, I could get the length of the minute hand, because I want to know how long is the minute hand. So go ahead and do all that. So I get approximately 10.61. Okay. When I add those together, I'm going to have at the end, I'm going to have to square root the whole thing to get my answer. So I ended up just typing that in to save some time. So I think it was in inches. So I'm going to say inches. Okay. All right. So next thing. It's a Ferris wheel. So this time it's not centered at 0, 0. It's 40 feet off the ground, and the radius of the Ferris wheel is 30 feet. So point P is shown at 0 radians. So think of it like your radius is 30, and then you got an extra 10 right here. So calculate how high off the ground point P is at pi over 12 radians. So pi over 12 would be like, I took my half circle here and I divided it into 12 equal slices for this half. So pi over 12 is going to be like something like that. I got to fit 6 of them into this 90 degree and another 6 slices into this 90 degree for 12 total in a semicircle. So your radius is 30. So the x coordinate is 30 cosine pi over 12. And the y coordinate is 30 sine of pi over 12. So let me fix that. That's sloppy. So really the y coordinate, and that's just to right here to the center of the circle. So that would be this y coordinate right there. I have to add 40 to that. So I'm going to say 40 plus 30 sine pi over 12. Okay. Now, if I wanted to type it into my calculator, I could. I just have to make sure that my calculator is in radian mode. So depending on what calculator you have, make sure, if you want to do it, because there's so many different calculators out there, just do a search for the name of your calculator and changing it from degree mode to radian mode, and that'll do it. So I'm going to type it into my calculator right now, and I'm going to get, let's see what it is, about 48 feet. Okay. Pi over 2 radians is actually right up here at the top of the circle. So this one's easy. I don't really need to do anything. It's almost like I just have 30 plus 30 plus 10. So that's 70 feet. Okay, I guess I could have put feet right here for this. 5 pi over 6. 5 pi over 6, that's right there. It's like I take half a circle, divide it into 6 slices, and I need to count 5 of them. So it's going to be right there. So the y coordinate is going to be, really, it's going to be 30 sine 5 pi over 6. That's the y coordinate. I don't really care what the x coordinate is because I want to know how high above the ground it is. So that's just the distance right here, this vertical piece. So I have to add 40 to that. So it'd be 40 plus sine of 5 pi over 6 feet. And again, make sure you're in radian mode, type it into your calculator, and I think I'm going to get around 55 feet. Okay, I rounded to the whole number. 5 pi over 3. All right, let me do a little erasing here. So this was 30 and this was 10. 5 pi over 3. So pi over 3 is divide half the circle into 3 slices. I need to go another 2 out of 3. So I think I'm going to end up like over here somewhere. Okay, it's kind of like I divide this half circle into 3 slices. So if I did that, just so you could see it, it'd be like, here's my first slice, here's my second, here's my third. And then I have 3 up here. So all right, so this coordinate is going to be, the y coordinate is really all I need. Radius is 30 again, so it's going to be 30 sine 5 pi over 3. Now, here's the thing. This whole thing's 40. This 30 sine 5 pi over 3 is really just this coordinate. So really, I need to do 40 minus that distance to get how much is left, how much is off the ground. So 40 minus sine of 5 pi over 3. That'll be my answer in feet, okay? Again, radian mode, type it into your calculator. I think it gives me about 14 feet. All right, number 2, as you go around on the Ferris wheel, at which positions would you be 60 feet off the ground? So 60 feet. All right, so we got to think about this here. So down at the bottom, you're only 10 feet off. So down here, you're at 10 feet. Up at the top, we said 70. Right in the middle, you're 40. So somewhere between 40 and 70. So 60 would probably be, you know, somewhere up here. Okay. You could also be, I guess, in the same exact position over here. Okay, so you know, I don't know if we actually know that exact answer. I don't know why this. Oh, 0 pi over 12 is right there at the red line. I don't know why it has that there, but so yeah, I would say somewhere in here we'd have to go, because this is 30 plus 10. To get to 60, we'd need another 20. Don't go all the way to the top, that'd be another 30. Somewhere between probably between pi over 4 and pi over 2, somewhere between there. So I would just say but then we'd also have another one somewhere between pi over 2 and 3 pi over 4. All right. So what is the highest and lowest above ground the windmill blades will reach? Where's the windmill? Oh, I need to give you guys a picture here. Give me a second here. Okay, so our windmill is going to be, I'm going to give you a picture here. Here's the ground. Here's my windmill base. And then the windmill is going to be up here. Okay, kind of like that. So I need to give you some numbers here. So the base is 200 feet tall. It has 3 blades that are 120 feet each. So the blades right here, 120 feet each. And the base is 200 feet tall. So 200 feet right there. Okay, so how far off the ground is it? I'd have to do 200 minus 120. So this is 80 from the bottom point there. So what is the highest and lowest above ground the windmill blades will reach? So the highest would be up here at the top. So you'd have to add 120 to this 200. So at the top, it would be at 320. I'll say feet. I didn't put units on there. The lowest would be down at the bottom, so that would be 80. Okay. What angle would a windmill blade make in the highest and lowest position, assuming 0 radians is directly to the right of center? So this is 0. So at the top, that would be pi over 2. because it's like, you take half your circle, you're dividing it into 2 sections. And at the bottom, that would be 3 pi over 2. What does the expression 120 sine of 4 pi represent in this situation? So that would be kind of like right here where this is. Pi over 4 would be like, you take your half circle here, divide it into 4 equal sections. I get rid of this blade here just so you can see a little bit better. It's kind of like I have, 1, 2, 3, 4 sections. So 120 sine pi over 4, this would be the y coordinate. At pi over 4. And that would be like assuming that the center is 0, 0. So I'm going to say assuming, can't spell. Oh, let me just erase that. So right there, that would be the y coordinate. It'd be 120 sine of pi over 4. All right. So if I wanted to find the full height, above the ground, I'd have to add 200 to it. How high is the top of the blade when it's at an angle of 11 pi over 6? So let me erase some of this stuff here. 11 pi over 6. So it's like I did almost a full circle. It's like right there. Okay, so how high is it? Well, this was 200, which would make this 80. Radius is 120. So this y coordinate is 120 sine of 11. I don't have enough room to move this. 11 pi over 6. So that's the y coordinate. So the whole thing's 200. Since I'm below it, I would subtract it from that. So I'd say 200 minus sine of 11 pi over 6. Okay. All right. One more of these. The center of an airplane propeller is 13 feet off the ground. So here's my center, 13 feet off the ground all the way down to the bottom. And the radius is 3 feet. So you basically have a circle right here. Looks like that. The blades of the propeller are set to pi over 6, 5 pi over 6, and 3 pi over 2 radians from 0 radians directly to the right. So directly to the right would be right there. What's the height of the tip of each propeller in this position? So this one here, it'd be 13 plus 3 sine pi over 6. This one here, because it's above the mid where the center is, this would be 13 here plus 3 sine 5 pi over 6. And then this one here is at the bottom. The radius is 3, so I'm just going to subtract 3 from 13. So this one would be at 10. All right, thanks for watching. Hope you enjoyed this video, and we'll see you next time.